Hi, my name is Peter Savini. I work for the Ceph team at Canonical, and I'm going to present MicroCeph simplifying storage. Quick high-level overview, 10,000 meter overview. What is Ceph? Software-defined distributed storage. You could think of Ceph as a kind of software RAID that distributes data across many different storage nodes. Ceph favors reliability and consistency. In CAP terms, it would be consistency and partition tolerance over availability and partition tolerance. Ceph is highly scalable. So you see in the architecture diagram below, clients talk directly to storage nodes with no intermediary and no gateway in between that could act as a pacemaker. Ceph offers unified storage. What that means is you can get block devices, you can get file systems, and you can get S3 compatible object storage from Ceph. Problem statement, why MicroCeph? Well, deploying and operating a Ceph cluster is a complex thing. You have distributed components and configurations. You have a pretty complex bootstrapping procedure, and operating this cluster is also not an easy thing. Hardware requirements are also non-trivial. You can't just install a package on a laptop and be done. This operational complexity impacts Ceph adoption among users and impacts focused on smaller user cases primarily. What is MicroCeph? MicroCeph is a single package Ceph cluster. It's an all-in-one snap package, 4 commands to get a functional cluster, 3 of them set up, and 1 to check status. And only 1 node required. It works on your laptop. Functional Ceph install as an example. This would be useful for testing and lab installations. You install the snap, you bootstrap a cluster, and you add some disks to the MicroCeph cluster. With MicroCeph, we have implemented the ability to use loop files as storage backends. So what this would do is create 3 loop files of 2 gigabytes each and add this to the storage cluster. And you're done. You have a healthy Ceph cluster with 3 simulated OSDs running. A few words around the snap package format. Snap packages isolate all the user land in a single package. You just need a kernel, network, and block devices from the host system. This gives you a consistent environment across operating system, and access to the host is confined for safety, security, and robustness reasons. Snaps are easy to build and easy to distribute. You could put a snap package on an USB stick and go to an offline site with it. Snap standardized risk-through channels. In MicroCeph, we use 3. You would have the stable channel where we publish production-ready snaps. You would have the candidate channels for release candidates. So you could use that to test upgrades, for instance. And you have the edge channel where all the development happens. So every time we push a pull request, the edge channel gets updated and you can test the very latest and greatest. A little bit about MicroCeph architecture. We have a service management daemon that talks to a cluster database where configuration is stored and which manages the Ceph daemons. And a CLI command line interface that connects to the MicroCeph service daemon through an API. The service management exposes an API. Everything you can do with MicroCeph, you can do through the API. All the interactions like enabling, disabling, migrating services, querying block device info, adding, removing this, etc., etc. Everything through the API, which is very useful for integration. And the command line interface is just another API client. A few words around scalability. We have already seen MicroCeph scales down very well. You can go with a single node and a single disk. And for scaling up, we implemented automatic failure domain rules. This means that the Ceph crush rules are automatically adapted from a single node OSD level failure domain to a multi-node host level failure domain as a cluster grows. Also, in the other way, if you scale down a cluster, the failure domain will go with it. What this means is that single node clusters work out of the box, and as you scale up, you get added safety automatically. Larger failure domains are available via custom crush rules. That's implemented in Ceph. MicroCeph itself doesn't have a concept of rooms or racks or any other larger failure domains, but it won't interfere with custom crush rules if you need them. How far can you scale up? Well, Ceph itself has excellent scalability, and MicroCeph is mainly bound by the Raft algorithm of the configuration database. Performance-wise, we basically have the same performance characteristics as Ceph. MicroCeph is not sitting in a data path for any I/O requests, so it excels at high bandwidth and highly parallel I/O, low bandwidth, low latency I/O is a little bit more challenging, same as with Ceph itself. How would you consume storage from MicroCeph? Already noted that we have three types of storage here: block devices, file systems, and object storage. Firstly, I'm going to talk a little bit about object storage. With the Rados gateway, we have an S3 compatible object storage, and we ship management and tooling for that RGW services in MicroCeph. Enabling RGW daemon on a single node is as easy as MicroCeph enable RGW, and that gets you set up with an Rados gateway on this node. We also package the standard Rados gateway admin tool for zone configuration, user creation, managing services, etc. Accessing the Rados gateway would be with standard S3 clients like S3 command, Boto, etc. How would you get a block device? This is where RBD comes into play. RBD is the Rados block device system. Support for block devices is available for Linux, Kubernetes, OpenStack, libvirt, LXD, Windows, and via NVMe over Fabric. One caveat for the Linux kernel: the RBD program that comes with MicroCeph can, for security reasons, not access the kernel. So for creating block devices there, you would need the distribution package. We saw a little bit small cluster for local development already. How would you go with into production with MicroCeph? First thing is Ceph of scale. We already saw that. There's a 3-node minimum recommended for safety for Ceph, and same goes for MicroCeph. For MicroCeph, you would inhibit the default automatic snap upgrades, so you can perform no downtime iterative upgrades with Ceph. You have tools to place services. You can scale services up and down individually as you require. We also support NVMe, WAL, and DB devices for performance. Security feature-wise, we support separate public and cluster networking in MicroCeph for better isolation and also throughput. We also support RGW, SSL, TLS frontends, and we have built-in full disk encryption for data disks. So this covers MicroCeph in production. I'm going to demo a short demo for a 6-node cluster and how to configure Rados gateway object storage and how to get an RBD volume from it. We assume we have 6 nodes already configured, so we can SSH into every one of them. And yeah, so I have sped up this demo a little bit so that you don't have to wait for downloads and things like this. So we're going to SSH in a for loop into each of the nodes and do a snap install MicroCeph here. By default, we're getting the current stable release, which is Reef. And then once it is done, we're going to set up a bootstrap this cluster. Bootstrapping happens on a single node, like with a single node setup before. We are going to issue a MicroCeph cluster bootstrap command. We could have used any node here, but I'm choosing node 0 for this exercise. And checking status here, we see we have a single node in there with 3 services running and 0 disks. So now we're going to join the rest of the nodes in here. So the way we do this, we get the token that embeds credentials for allowing the node to join. We do this by running cluster add on the first node, and then on each of the other nodes, we are going to issue a command cluster join using the token that we got before to allow the node to join the cluster. So once this is done, rerunning the status just to prove we have now 6 nodes in the cluster. And here we are. We see that the first 3 nodes got services. All of them could have disks, but we have no disks at all in here for now. So let's add some disks. I gave each of those nodes 2 disks. So we're adding SDB and SDC, the 2 disk devices. And we do this by issuing a MicroCeph disk add command for this. Again, iterating over all the nodes in the cluster. Getting a short message for each of the nodes. We successfully added 2 disks here. So that's great. Checking status again. Yeah, we now have 2 disks each, and the Ceph status, we now have health OK and 12 OSDs in total, as it should be. As a next step, we're going to enable Rados Gateway. Could use any node again, but I'm choosing node 0. And this is reflected in the status output as well. And now, in the next step, we're going to create the user for Rados Gateway and set some secrets on it we can use later on. I have prepared a configuration for the S3 command. We didn't install any SSL certificates, so I've turned SSL certificates off here and gave it a host space of node 0. So with the S3 command, we're going to test now if our Rados Gateway actually works. First, making a bucket, just naming it my bucket here. Yeah, and successfully created a bucket. Now let's upload some image to it. Into this bucket, and that's a success as well. Let's download it via curl. Yeah, curl refuses to put this to standard out, so I'm grateful for that. Let's save it into a file, and just to see if we actually got the correct file, going to compare this with diff, and yeah, diff didn't mention any differences between 2 files, so these are indeed the same binaries. In the second step, we are going to enable Rados block device and use it as a local block device. To do this, we need to install a Ceph client here on this machine and configure some Ceph configuration. The minimal Ceph configuration we have here is just pointing it at the mon host, pointing it at node 0. We have 3 hosts that are running monitors, so we could add those other 2 as well. But for simplicity, I just took the first one. So to actually access these nodes, I also need credentials. We're going to do some administrative steps here as well. So I'm just grabbing the keyring of the admin from MicroCeph and putting it into a local file where the Ceph clients can find it. So here it is, and written to a well-known location. Yeah, with this I can run a Ceph client locally, access status here. Again, we can see health is okay, so that's fine. Now, listing the pools we have in Ceph, we can see there's some Rados Gateway related pools, but we don't have an RBD pool yet. So let's create one. It's a small pool only. Let's give it 16 page groups. Next, enabling the application RBD for this, so that we have RBD here. We're checking if there's anything in the pool, RBD LS. Naturally, there's nothing in there yet because we haven't created anything. So let's create an image. So RBD create my image with a size of 4. And yeah, that's actually a typo. I just need to see RBD create image. And here we are, showing some details about this image. And yeah, so let's actually make use of it. And this is done by the RBD map command. This maps the remote image into a block device on the local system on my notebook here. So we got a block device here, RBD0, and just to see if it works, create a file system on it and put a little bit of data on it so that we can see, we can verify functionality here. I can also check its size. We made the image 4 gigs. It's reporting almost 4 gigs. So that's nice. Yeah, creating a file works as well. So this looks good. Yeah, the RBD and Ceph binaries we used here are from the Ceph common package that I just installed on this machine. Yeah, as a final step, I'm going to show how to inhibit refreshing the snap automatically, because typically for a production environment, at least, you would want to make this an explicit step so you can do it in a sequential fashion. And the way you do is you SSH into each of the nodes and issue the snap refresh -- hold command for the MicroCeph snap, and this will prevent any automatic snap refreshes. That was all for this demo. Yeah, we set up a 6-node cluster and made it available for object storage and block devices. So next up, I'm going to talk a little bit about MicroCeph integrations. So this means which projects that make use of MicroCeph and how you could integrate this into your clouds. First up, there's Sunbeam, the OpenStack on K8s project from Canonical, which makes use of MicroCeph internally. You can also make use of MicroCeph together with MicroK8s to provide storage for a K8s cluster. And similarly for LXD and MicroCloud, also providing storage for these cloud environments. I'll talk about the Juju integration in a bit. Last but not least, we have a small MicroCeph action that provides S3 for your CI workflow. Juju Charm MicroCeph. Juju is the orchestration engine created by Canonical that allows you to deploy cloud components with operators. And there's a Charm MicroCeph operator we implemented for Juju, which would provide storage integration for OpenStack, Kubernetes, and other cloud components. Just as an example, this is how you would deploy a 6-node MicroCeph cluster via Juju. That is Juju deploy MicroCeph, give it the number of nodes you want to use, and some storage options. Short look at what's next. We're currently working on disaster recovery for Rados block devices that would provide MicroCeph with remote cluster awareness. That means you could manage one cluster from another, and in the next step, provide RBD mirroring support in MicroCeph. This means you could mirror RBD block devices from one cluster to another cluster for disaster recovery purposes, for failover, workload migration. So these are the things we are going to implement there. And those could be either journaling or snapshot based, depending on your requirements. A look farther ahead, we will create a squid release for the upcoming Ceph major release. This will be an LTS release for MicroCeph, so long-term support for the snap. And we're on future work. We're looking to implement hardware acceleration via Intel QAT in MicroCeph, so to give Rados Gateway encryption and compression support via hardware. That's all for this talk. Thank you for listening. Get in touch via Matrix. I've left the URL here. Here's some more resources to get more details about MicroCeph. Thanks again, and see you around.